In this video, we want to learn how to construct box and viscous plot. So in this slide, you can read the steps to follow in order to construct a box and viscous plot. The most important things you have to know that how to calculate the upper inner fence and then the lower inner fence. The upper inner fence Q3, the third quartile must plus with 1.5 times the interquartile range Q3 minus Q1. But to find the lower inner fence Q1 minus with 1.5 times with interquartile range. Why we need to calculate the upper inner fence and then the lower inner fence? Because we want to determine whether the data has outlier or not. We can construct our box and viscous in two ways, either horizontal or vertical. Before to construct box and viscous, we need to know the minimum value and then the maximum value in our data. The next is the first quartile, the median, and then the third quartile. When we are construct box and viscous plot, we need to calculate the lower and the upper inner fence. If our data lies within the upper and the lower inner fence, so the data has no outliers. If we calculate and then we get the value for upper inner fence less than the maximum value, so the maximum value will become outlier for this data. The same goes to if we get the value for lower inner fence more than the minimum value, so the minimum value will become the outliers. Shape of the data distribution when the viscous are the same length and then the Q2, the median is in the center of the box, so this is the symmetrical distribution. When the left viscous is shorter than the right viscous and the median is nearer to the Q1, so this is the positively skewed distribution. The left viscous is longer than the right viscous and then the median is nearer to the Q3, so this is negatively skewed distribution. Example 6. Display the data in a stem and leaf diagram. In your stem and leaf diagram, make sure you write your key. You can choose any data to put as your key. And then your data must be arranged in ascending order. Now we want to find the first quartile Q1. So the R observation, R equals to 1 over 4 times 25 equals to 6.25 observation. So Q1, the R observation must be round up to 7th observation. The 7th observation equals to 50. So our first quartile equals to 50. So Q2, the median, so R equals to 2 over 4 times 25 equals to 20.5 observation. So Q2 must be round up to 30th observation. So the 30th observation equals to 61. Next is the third quartile. R equals to 3 over 4 times 25 equals to 18.75 observation. So Q3, the third quartile, must be round up to 90th observation. So the 90th observation equals to 66. To calculate the upper inner fence, Q3 plus 1.5 times interquartile range, Q3 minus Q1. So Q3 is 66 plus 1.5 times 66 minus 50. Calculate, we get upper inner fence 90. Next, the lower inner fence, Q1 minus 1.5 times Q3 minus Q1. So Q1 50 minus 1.5 times 66 minus 50. Calculate, so equals to 26. Now we can construct our box and viscous plot. Make sure label for lower inner fence, upper inner fence, minimum value, maximum value, then Q1, Q2, Q3. As you can see here, our data lies within the lower and then upper inner fence. So this data has no outliers. And then we can see that the data is negatively skewed or skewed to the left. The data is negatively skewed as the left viscous is longer than the right viscous. Q2 is nearer to Q3. Example 7. To construct box and viscous plot, we need to determine minimum value, maximum value, Q1, Q2, and then Q3. Next, to find the outliers, we need to calculate upper inner fence and then lower inner fence. For this example 7, the number of observation is 23 and then the minimum value 51, then maximum is 77. So here we need to find first is the first quartile, Q1. So the R observation, R equals to 1 over 4 times 23 equals to 5.75 observation. Since our R observation is not an integer, so our Q1 must be the 6th observation. And then again referring to the previous time and leaf, so the 6th observation equals to 64 Fahrenheit. Q2, the R observation is R equals to 2 over 4 times 23. So equals to 11.5 observation. Since the value of R is not an integer, so our median Q2 must be the 12th observation. So the 12th observation from the previous stem and leaf diagram is 68. Next is the third quartile. So R equals to 3 over 4 times 23. So equals to 17.25 observation. Therefore, our value for Q3, the third quartile, must be the 80th 18 years, the 18th observation, which is equals to 70. We want to find the upper inner fence and then the lower inner fence. So upper inner fence equals to Q3 plus 1.5 times Q3 minus Q1. So Q3 70 plus 1.5 times 70 minus 64. Calculate. So upper inner fence equals to 79. Lower inner fence equals to Q1 minus 1.5 times Q3 minus Q1. So Q1 64 minus 1.5, 70 minus 64. Calculate. So lower inner fence is 55. Now we can construct our box and viscous plot. We can see that the minimum value 51 is outside the fence. So this value 51 will become outliers. And then we have a new minimum value which is 59. We have to make sure all the data must be inside the fence. So the data that outside the fence will become outliers. Don't forget to label these outliers and then label for our lower inner fence minimum value, value for Q1, Q2, Q3, and then maximum value. The last is the upper inner fence. The general shape of the distribution can be determined from the value we get for mean, median, and mode, and then we can illustrate as the following diagram. As we have the value for mean, median, and mode is equals, so this distribution is symmetrical. If we get the mean is the largest value and then the mode is the smallest value, so this is the distribution is skewed to the right or positively skewed. If we get the mode is the highest value and the mean is the lowest value, so this is the skewed to the left or negatively skewed for the distribution.